All right, I thought I would make a video to explain the formulas that we've been using to find Q1, E, and P1 for a 2x2 game in order to find the mixed strategies, the mixed optimal strategies, when the game is not strictly determined. So we're going to start off by looking at an example, a concrete example, and then we'll move to a more general description. So we've got this payoff matrix here that happens to be 1, 4, 2, 1. And we know that Q is the column player strategy. And that would be Q1, Q2. We know Q1 and Q2 are both positive, or at least non-negative, and they have to add up to 1 because they're probabilities. So Q2 has to be 1 minus Q1. So let's think about this, about the two possibilities. The row player could choose row 1. And so if the row player chooses row 1, I've written this as E1, as expected value 1. We would use row 1, which is 1, 4, and multiply by the column probabilities, Q1, Q2. And so we would have this right here, this, I'll highlight it, Q1 plus 4, Q2 for our expected value for row 1. Now, if the row player chooses row 2, we might have a second expected value. So we'll choose the second row, 2, 1, times that Q column matrix, and we would have this second E2 right here, which is 2 Q1 plus Q2. Now remember up here that Q2 is the same as 1 minus Q1, so we've made that replacement here, and we've come up with some simplified versions for E1 and E2. All right, now, so take a look here. I've graphed these two lines, right? And so these are E values for different Q values. And notice Q1 has to be between 0 and 1. So I've only graphed it on that interval. And so E1 is a line that has a y-intercept or an e-intercept of 4 with a slope of -3. E2 has a positive slope of 1, okay, and it has a y-intercept of 1. Now the column player wants to minimize their losses. So remember, the big positive number is a big loss for them. And so they want to pay as little as possible to the row player. So they want the maximum of E2 and E1 to be as small as possible. So if you notice, as we go from left to right, the bigger of E1 and E2, it starts off to be E1 until we get to this point right here. And then the bigger of these two goes off in this direction. So the minimum, the smallest of those, maybe I'll use purple, the smallest of those would occur right here. All right, and so that's where we want to be if we're the column player. We're going to minimize our losses. So we're looking at the biggest possible loss between E1 and E2 and choose the smallest place. So that's where we want to be right there. So really what we're trying to find is the intersection of E1 and E2. That will ensure that the smallest E, that will ensure the smallest E no matter what row the row player chooses. So if we set those two equal, so I'll go back to the orange here, we've got this is E1 and this is E2, we can solve that for Q1. It's just a linear equation. So Q1 is 3/4, and our Q2 would be 1/4. And if you look back at that graph, that looks quite possible that could be 3/4, right? Right there. And also notice if we put this Q1 in to either one of these formulas, let's put it into this one here, then we would get our E value of 7/4. And it would also work if we put it into the first equation because it's an intersection, right? And so that is right here, 7/4, just under 2, 7/4. Now, that will be the E value, okay? That's the expected value. We've been calling it capital E. Now, we could do a similar process to find the P1 and the P2. All right, again, we would choose column 1, find that formula, choose column 2, find that formula, set them equal, find the intersection point. All right, so now let's generalize for any matrix A, B, C, D. So we're going to repeat this process again. Q is Q1, Q2. It's a column matrix. Q2 is 1 minus Q1. So it's repeating the same thing we just did, only now we're just using letters A and B instead of the numbers that we had in our previous example. And we've got two equations for E1 and E2 when we multiply those together. And when we set them equal, here we have it. This is our formula for Q1. Just a little bit of algebra to solve for Q1. And that's the formula that we've been using. D minus B over A plus D minus B minus C. Kind of cool. Now, notice also that if we put this value for Q1 into either one of those, either E1 or E2, we would get the same thing. That's the value of E. So we're going to put it into this one right here. So we're putting that in for Q1. And when we do, we use some algebra again, we've got our formula for E, expected value, AD minus BC over A plus D minus B minus C. Now, in this one, I actually did repeat for the row player. Now notice, if we're doing this for the row player, we're trying to find the P strategy, P1 and P2. And again, I didn't write it, but P2 is 1 minus P1. And in this case, if the column player plays column 1, that's A, C, notice I put the P1, P2 in front because if you remember our E equals PAQ. P has to go in front of the A matrix. Q goes behind. Order makes a difference. So we put the P in front of that column, and when we do that, we get A P1 plus C times 1 minus P1. And then if we try the second column, we get this second amount. And the reasoning is very similar to what we did before. We want to set those equal to each other. And you'll just use some algebra when you do that to solve for P1. So P1 is D minus C over A plus D minus B minus C. And there you have it.